Hi, welcome to my video on the relations among trig functions, and this video is on the negatives. That's negative angle. So let me explain negative relations. So let's look at the unit circle, and this the unit circle which has a radius of 1. So this circle has a radius of 1. Now I'm going to look at also ASTC, add sugar to coffee. Add sugar to coffee. So add sugar to coffee tells me where the trig functions are positive. This first quadrant is all. S is for sine, tan, and cos. So if sine is positive, that means it's reciprocal, which is cosecant is positive. If tan is positive, it's reciprocal. Cot is positive. If cos is positive in 4, then it's reciprocal, which is secant, will also be positive. So if sine and cosecant are positive, that means the other 4 are negative. If tan and cot are positive, that means the other 4 are negative, etc. Now, let's draw a rotation. And this rotation, we'll call this rotation from here to here, we'll call it theta. That means the central angle is theta. Let's also look at the negative rotation. So if this is theta, let's look at the rotation of a negative theta. So let's say this is negative theta here. And again, we draw a terminal arm, and this is a negative theta rotation. So this angle in here is negative theta. So the reference angle here in the first quadrant and the reference angle in the second quadrant are both the same. So let's drop a perpendicular down from this point here, perpendicular, and drop a perpendicular here. So this perpendicular is the same because these two triangles are congruent. So that means that if we look at, this is the y positive going up, and this is the y negative going down. And x is positive here. X is positive going to the right. And the hypotenuse unit circle, hypotenuse is 1 in this triangle, and hypotenuse is 1 in this triangle. So let's look at the sine of negative theta. So the sine of negative theta, this is negative theta right here. So the sine of negative theta, opposite, which is negative y over hypotenuse is 1. So that's negative y. Now, the sine of theta, which is in the first quadrant, the sine is opposite, which is y over hypotenuse is 1. So that's a y. So that means that the sine of negative theta, both of them are y's, but they're opposite of each other. So the sine of negative theta is the negative sine of theta. And let's look at cosecant. Cosecant of negative theta. The reason I'm looking at cosecant, because cosecant and sine are reciprocals of each other. So that means cosecant is going to be hypotenuse, which is 1 over of negative theta here. It's going to be 1 over negative y, which is negative 1 over y. And that means the cosecant of theta, which is right here, is hypotenuse, which is 1 over y. And again, as you can see, that these are opposites of each other. That's negative y, and that's 1 over negative 1 over y. This is 1 over y. So the cosecant of negative theta is equal to the negative cosecant of theta. Because the reference angles are the same, sine is positive here, sine is negative here. So that's why they're negative of each other. And let's have a look at cos of negative theta. The cos is of the negative theta is here. Cos is the adjacent over the hypotenuse. So it's the x over 1 or x over 1 or x. And the cos of theta Theta is here. Cos is the adjacent over hypotenuse, which is x over 1, which is x. And notice that in terms of cos, the cos of negative theta is equal to the cos of theta. Again, both the reference angle is the same in each of these triangles. Cos is the x. So in the first quadrant, the causes add sugar to coffee. Cos is positive in the first quadrant, and this is cos here, which is this c. Shift that c away from that line. This is cos. So cos is positive in 1 and 4. So that's why the cos of negative theta is equal to the cos of theta. And this would be true for secant of negative theta. So the secant of negative theta secant is hypotenuse over adjacent, so it's 1 over x. And the secant of theta in quadrant 1 is the hypotenuse, which is 1 over the x. And they're the same. So the secant of negative theta is equal to the secant of theta. Cos, so whatever cos is, secant is, because they're reciprocals. And again, with these two triangles, the reference angles are equal. And what about if we look at tan? The tan of negative theta. So tan, this is negative theta. Tan is opposite over adjacent, so that's negative y over x. And what about the tan of theta? Tan of theta is the opposite over adjacent, which is the y. So the tan of theta is opposite over adjacent, y over x. The tan of negative theta is the negative y over x. And notice they're same fraction, but they're opposite of each other. So the tan of negative theta is equal to the negative tan of theta. Again, both of these triangles have the same reference angle. Tan in this quadrant, all. Tan is positive in 1. Tan is negative in 4. So that's why the tan of negative theta is the negative of tan of theta. And cot is the same as tan. Oh, this is reciprocal. So the cot of negative theta is going to be cot is the adjacent over the opposite, so it's x over negative y. And the cot of theta is the x over the y. And as you can see, they're negative for each other, so the cot of negative theta is equal to the negative cot of theta. So whatever tan is, cot is, because they're just reciprocals of each other. Again, the reference angles. So that's the negative angles. So in sometimes when we do simplification of expressions or identities, we have the sine, cos, tan, secant, cot, etc. of negative theta, and we have to express it in terms of theta. So trying to explain why that works, which hopefully you'll understand. And just to make sure, let's do an example. What about the sine of 30? Again, the radius of this circle is 1. So 30 is, let's say right here, this is a 30-degree rotation. And we drop a perpendicular. And the hypotenuse is 1. So this rotation is 30. So this angle is 30. This is 60. So in this triangle, which has a 1, so this is, because I have a 1 for the hypotenuse, opposite 30 is 1/2, opposite 60 is root 3 over 2 when the hypotenuse is 1. You could also draw this in relation to not a unit circle and have the hypotenuse 2 and have this 1 and root 3 if you wish. So the sine of 30 is opposite over hypotenuse, so it's a 1/2 over 1, which is 1/2. Now what about a negative 30? So let's look at the negative 30. So negative 30 swings down here. We draw a terminal arm. We drop a perpendicular to the x-axis. And this is a 1 of a unit circle. So this x is root 3 over 2 in both triangles, but this is the y going down, so it's a negative. So the sine of a negative 30 is opposite over hypotenuse, which is a negative 1/2 over 1, which is negative 1/2. And as you can see, the sine of negative 30 is the negative sine of 30. This is a half, this is a negative half, so they're negative of each other. And that's what I explained just then. And what about the cos? But this time I'm going to draw the radius of the circle to be 2. So let's do 30 here. And the radius is 2. Drop a perpendicular. And we have a 30-degree rotation, so the central angle is 30, so this is 60. So because this is 2, we have a 1 and a root 3. So notice I made this 1, so I could have a half and root 3 over 2. Or I could have the hypotenuse 2, and the triangle would be 1 root 3, 2. So the cos of 30, cos is the adjacent, which is root 3 over the hypotenuse, which is 2. And what about the cos of negative 30? So negative 30 goes this way. And again, I have the hypotenuse to be 2. Drop a perpendicular. And since this is 2, this is root 3, x is positive. This is, the y is, this is 30 here. This is 60. So this is negative 1. So the cos of negative 30, which is this reference angle here, cos is the adjacent over the hypotenuse. And notice in terms of cos is positive here in 1, positive in 3, because cos is the x. So that means, as we illustrated before, the cos of negative 30 is equal to the cos of 30. So if you had negative theta, then this would be theta. So no matter what angle you pick on this circle, if you do the negative of it, then in terms of cos, they'll be equal. In terms of sine, they'll be negative of each other. And just to do one more for tan, remember tan is, in terms of negative theta, tan is the negative of it. Because one is in whatever quadrant you're in, then it's going to be negative in the other one in relation to negative theta. So let's do the tan of 120. And we're going to use the radius to be 2. So 120 is 90. So there's let's say that's 120 rotation. And there's the terminal arm. Drop a perpendicular. So that's 120 degree rotation. This is a 60 here. So this angle here is 60. This is 30. Hypotenuse is 2. This is a 1. And opposite 60 is a root 3. The y is positive, and the x is negative. So the tan of this 120 rotation is opposite, and even though the rotation is 120, you work it out in terms of the reference angle of 60. So tan is opposite, which is root 3 over adjacent, which is negative 1. So it's a negative root 3. So what about if we do the negative 120? So negative 120 starting from here is negative 90. And there's, let's say this is a negative 120. Terminal arm is drawn out, going through this end of this rotation, perpendicular to the x-axis. And since this is a negative 120, this is a 60 degree angle from here to here. That means the reference angle is 60. This is a 30. Opposite the hypotenuse, hypotenuse is 2. Opposite 30 is 1. Opposite 60 is a root 3. But this is negative, so it's negative 1. The y is going down, so it's negative. So the tan of a negative 120 is the tan of this 60. Tan is opposite, which is negative root 3. Adjacent is negative 1. So that's root 3. So notice that in terms of 120, the tan of negative 120 is equal to, again, they're opposites of each other, negatives of each other. So that's the negative tan of 120. So the tan of negative theta is the negative tan of theta. That's what I'm trying to illustrate here. Tan is negative in this quadrant, and it's positive here. Remember, add sugar to coffee. All trig functions are positive here. Sine and cosecant are positive here, so that means tan is negative. And right here, tan is positive. So you can see that tan is positive in 3, positive in 1 and 3, so it's negative in 2 and 4. So that's why the positive rotation and the negative rotation are the negatives of each other in terms of the tan here. And again, that's the negative rotations. So, and if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.